we're going to move right on to Tim Glotch and a plethora of co-authors. Eclipse Science and Exploration Campaign at the Aristarchus Plateau. And there's Tim. 5 minutes, Tim.
All right. Thank you, Clive. So in the spirit of, I think, the one line in the Prism 2 solicitation that said science campaigns might be solicited in future solicitations, here's a science and exploration campaign at the Aristarchus Plateau. The case for this, I think, was made really nicely on Erica Jawin's white paper. It's the decadal survey this year, and we expanded upon that in a recent paper in the Planetary Science Journal that these figures that you'll see are taken from. Next slide, please. So we have a few key science objectives. You can see the traceability to the right. We want to determine how magma is generated on the moon in the absence of plate tectonics. Just about where we see these types of materials on Earth or similar granitic or rhyolitic materials on Earth. Plate tectonics and water are usually involved. We want to determine the magnetic or volcanic processes that led to the formation and modification of these materials in 3 places on the plateau: Aristarchus Crater, the Cobra Head, and Herodotus Mons. We want to determine the extent to which these lithologies in the Aristarchus Plateau are related to regional basalts and mafic pyroclastic materials on the plateau. Next, please. Next, please. Once when we get to the slide, what you see is that there are three areas that are all very low in iron. These also correspond in diviner data to a signature that is even more felsic than Highlands materials. The first is the Aristarchus crater floor. This is probably the highest silicic signature that we see in diviner data. And we hypothesize that this is a exposure of plutonic granitic rocks. I think if there's any place on the moon that we could go land where we might see something that really is representative of the rare silicic materials in the Apollo sample collection, it might be here. If we go to the Cobra Head next, we would be able to investigate volcanism, bimodal volcanism on the crater floor. I can go back to that last slide. And then if we go to Herodotus Mons up in northern Aristarchus Plateau, we would be able to investigate both silicic volcanism in the form of the small little volcano and pyroclastics that surround it. Okay, so now next slide, please. So I'll just step through these very quickly, one by one. We can land on the Aristarchus crater floor, low slopes, very close to the central peak with a precision landing. I think we could do this mission without mobility capability. We'd be able to do remote sensing of the central peak, which includes detections of pure plagioclase as well as likely more silicic materials. We would want stereo cameras, microscopic materials to investigate the area around the lander. Thermal IR spectroscopy to investigate the low iron bulk mineralogy, and gamma ray spectroscopy to get major and some trace element abundances. All these areas are very high thorium as well. Science will be enhanced by mobility, sample return, which will be a theme for all 3 of these, as well as Raman, visible near infrared, spectroscopy, and geochronology. Next slide, please. Things get really interesting at the Cobra Head. Here you see in the upper left image that shows the mouth of Valles Schroederi. It's where the mafic lavas that carved the rill are sourced, and you also see these very bright materials that are silicic based on diviner data. So here we would need mobility capability. We'd need mobility on steep slopes. And so this is harder. It's more complicated.
1 minute, Tim. 1 minute.
Thank you. The instrument package would basically be the same as the Aristarchus Plateau or Aristarchus crater with the addition of visible near infrared spectroscopy to help characterize the mafic materials in this region. And enhancing capabilities would include sample return, Raman, and geochronology. And then finally, if you go to the last slide, we could sum up this campaign at Herodotus Mons, which is a volcanic, a silicic volcanic dome, a little bit smaller than the Grootheisen domes, which is a target of Prism 2 solicitation, but it peaks out through mafic pyroclastic materials that are iron rich, and water rich based on remote sensing data. So here we would include previous instruments from the last 2 landing sites, in addition to a neutron spectrometer to help characterize the water content of these rocks. And again, sample return, Raman spectroscopy, and geochronology would all be enhancing capabilities. So I think the key is, even though we're going to Great and domes with PRISM 2, I think we can do a lot more here, and we can further characterize these materials that are barely represented in the Apollo sample. I'll end there. Thank you.
Thanks, Tim.